fractional decomposition. I'll start with an example. Say we want to find integral 5 over 2x plus 1 divided by x minus 2. Yeah. When you're going to solve it, let's rewrite our function, which is 5 over 2x plus 1 x minus 2. And using some results from advanced algebra, that fraction can be decomposed into partial fractions. One with denominator 2x plus 1, and the over with denominator x minus 2. Some unknown numerator, so we're going to put a and b. Now to find a and b, we're going to multiply left and right side by common denominator, which is denominator over right side, 2x minus 1 pi times x minus 2. So if we do that, we're going to get 5 equals to a times x minus 2 plus b times 2x plus 1. Now if we substitute x equals to 2 in that expression, we're going to get 5 equals a times 0 plus b times 5. So we're going to get b equals to 1. If we substitute x equals to negative 1/2, we're going to get 5 equals a times negative 1/2 minus 2 plus b times 0. So we're going to get 5 equals negative 5a over 2. So we conclude that a is going to be equal to negative 2. Now we know what a and b are. We're going to substitute them into our expression function. And that expression, which we obtained, is going to go instead of that fraction, a rational expression inside of our integral. So what we're going to get is following. So our original integral 5 divided by 2x plus 1 divided by x minus 2 dx. It's going to be equal to integral of, now instead of having this fraction here, we're going to write its equivalent form, which is this guy. So we're going to write down negative 2 over 2x plus 1 plus 1 over x minus 2. And now for that is going to be 2 easy integrals. So we're going to get negative 2x plus 1 plus natural log of x minus 2 plus c. And then they're going to be done. That's going to be our final answer. So that's how fractional decomposition works. So in general, picture looks like this. So we have a rational expression. So we have polynomial over polynomial. Somehow just imagine that in that polynomial on the bottom, we have some expression. And in that expression, we have x plus b to the power and some coefficient of q. then corresponding fractional decomposition is going to look like A 1 over ax plus b plus a2 over ax plus b squared and so on, plus an ax plus b divided plus fractional decomposition, which will correspond to the remaining stuff. Okay, for example, if we have fraction 2x plus 1 over x plus 3 squared x minus 1, we're going to decompose it as x plus 3 plus x plus 3 squared plus x plus 3 cubed plus, and we also have to take into consideration of x minus 1, because it's to the first power. We're going to write it only once, and then we're going to write down a, b, c, and d on top. One more example. If I'm looking for fractional decomposition of expression, which looks something like x cubed plus 3 divided by 2x plus 1 squared, x minus 1, x minus 2. And corresponding fractional decomposition is going to look something like, we're going to write down 2x plus 1 and then 2x plus 1 squared, because in our original expression we have 2x plus 1 squared right here. So we're going to write down corresponding decomposition 2x plus 1 and 2x plus 1 squared. Then we're going to take care of it x minus 1, because it's to the first power, we're going to write it only once. And x minus 2 only once, because it's only to the first power, and then we're going to put letters on top, a, b, c, and d.